Here we go with page 3. So this is a molarity question again. This is the other common type of molarity question. How many grams of calcium chloride this time are required to make 500 milliliters of a 0.2 molar calcium chloride solution? And the way we're going to start this off is with the formula mass for calcium chloride, which I previously calculated to be, I need to look this up, I think it was 110.98. So I've already done this in a previous calculation. The reason why I'm starting with that is because the question is asking about how many, whoa, that's an M. How many grams of calcium chloride. So that's why I want to have this gram amount on top, because I just need to cancel this mole somehow. The way I'm going to cancel the mole is with the molarity. Remember that capital M is equivalent to 0.200 little mol over liter. That cancels the moles, but creates a new problem, which is the liters. And because I've got a 500 milliliter amount, and that doesn't cancel exactly with 1 liter, I'm going to just do this conversion factor next, which again solves the liter problem. But now I got the milliliter problem, which finally I'm just going to multiply by 500 milliliters. Whoops. And that cancels all the units except for the one that I want, which is the gram amount. Okay, when I calculate this, and with 3 sig figs, I'm looking at 11.1 grams of calcium chloride. Okay, so that's another type of, that's a common calculation when it comes to molarity. How many grams are required to make this volume, which is 500 milliliters at this concentration. Okay, so solution stoichiometry, it's coming back, stoichiometry that is. What mass in grams of calcium carbonate is needed to react completely with 65 milliliters of 0.12 molar HCl? So this is what we need to get started, is this value right here. So with the milliliters, converted to liters right away. That's 1,000 milliliters. I don't know what is going on with my pen today, but it is laggy, and hence the bad writing. I apologize yet again. 0.12 moles per liter. So right here we've got the milliliters canceling with milliliters, and then liters with liters cancel, and we've got moles HCl. That's how we get to moles once we have a sample volume and a molar concentration. It is totally not necessary to calculate the formula mass. In fact, it won't work for you. It won't work at all. So this is how we get moles out of concentration. Now stoichiometry is just like it always is. We go to the balanced chemical equation. We see that for every 2 moles of HCl, we're going to need 1 mole of calcium carbonate. The question is asking about the calcium carbonate, so that's why I put that up top here, how many grams. And since we're asking about how many grams, I'm going to need to calculate the formula mass, which of course is going to be per 1 mole when we do it. So we're just going to get this out of the way, and I'm going to calculate the rest right now. According to my calculations, we've got 100.09 grams. Okay, so it's set up correctly. And the result that I get with 2 sig figs this time is 0.39 grams of calcium carbonate. So if I use 65 milliliters at this concentration of HCl, how many grams exactly are required to completely neutralize this amount of HCl? Well, it turns out 0.39 grams of calcium carbonate. That's what we just calculated here. Okay, so that is stoichiometry. It's called solution stoichiometry because we had a molar concentration to start with. You do not calculate the formula mass for HCl. We have the molar concentration. However, to get the gram amount of calcium carbonate, we did calculate the formula mass. So it just depends on what the calculation is asking for. Now this question is pretty much going to be the same deal, except that instead of grams of the other reactant, we're going to calculate grams of this product, but it doesn't make any difference in terms of the setup. We're still going to start with the volume, converted to liters right away. times the molar concentration of silver nitrate. So again, we're not going to calculate the form mass here because it won't work. We have the molar concentration, which is moles per liter. Okay, now stoichiometry. So we say 1 mole of silver nitrate is going to produce 1 mole AgCl. Okay, since we're looking for the mass, we got to calculate the form mass for AgCl, which is 143.35 grams per mole. Okay, set up correctly. 3 sig figs to work with, 0.358. Okay, so in this reaction, 25 milliliters of 0.1 molar silver nitrate with excess sodium chloride is going to produce, on paper, we predict 0.358 grams of the product, which is, it's a solid product, silver chloride. Okay, so that is it for this question. That is another example of solution stoichiometry. Okay, so let me just clarify that this is spring 2017. This is the review session for Chem2A. I'm going to go ahead and just make an executive decision not to calculate this because this semester, which again is the spring 2017 semester, you will not see a question exactly like this on the exam coming up here. So I'm just going to say that. That's why I'm not going to do it here to save time. But keep in mind the previous questions I just got done doing. Yeah, those are fair game for the test coming up, but not this one. This one's, as I stated, is kind of the toughest one. I didn't put it on this year's test, or this year's test, but in future semesters I may. All right, so solutions. Moving on to a different topic here. Which of the two substances, ethanol or pentane, is more likely to mix with water? And without writing out an explanation, which you should do on the test if I ask this, I'm just going to say it in words. Ethanol has an OH group, which means that it's a hydrogen bonder, and water is a well-known hydrogen bonder. So these two right here are going to mix thoroughly. In fact, they are perfectly miscible, as we say, and you won't see any layers. They homogeneously mix. Pentane, on the other hand, is totally nonpolar, so will not mix with water. No chance at that, and that would form a two-layer system. Okay, so like dissolves like. These look a lot like each other. They both have hydrogen bonding. They're going to mix. Which of the two solvents, water or pentane, is sodium chloride more likely to dissolve in, and why? We've got charges here, okay, which means that this is an ionic compound, no question of that. Ionic compounds are very, very polar, and given that water is pretty polar, and this is very polar, like dissolves like, sodium chloride definitely is going to want to dissolve in water. It has no chance in dissolving in pentane. Pentane is very nonpolar. This is very polar. Yeah. Okay, water is the answer. That's why, generally speaking, ionic solids dissolve quite nicely in water because like dissolves like. Okay, so that's it for page 3. Let's move on to the next page.